and you can go ahead whenever you're ready.
Yep.
Awesome. All right.
I'll go first. Welcome, everyone. This webinar is hosted by ibpsa-usa and the Project Celsius. If you have any questions during the live session, please feel free to submit them anytime using the Q&A feature. Just click the Q&A icon at the bottom of your screen. First, I'd like to invite Afonso Hernandez to introduce Project Celsius.
Awesome. Thank you, Guangzhou. Yeah, so welcome again, everybody to this webinar. So we are Project Stasio. Project Stasio is an initiative that started a few years ago from the Architectural Simulation Committee at ibpsa-usa. And essentially what we wanted to do is to be better communicators of data, especially when it has to do with the impact of simulations and design. Next slide, please. For example, when we're talking to a client and the client or we're talking to our own architect friends, and they want to have some curiosities. They have some curiosities. They want to run some studies, and essentially we just try to get the approach, the right approach to simulations. Next slide, please. And we work with the data. We work in, as an organization ourselves, our team, Project Stasio, we work as and not only as communicators, but also as experts in, I guess, semantics on how to essentially convey the message. The message that has to make very complex ideas and very complex processes that happen in buildings, simple and understandable. Next slide, please. For example, this is one of the studies that we have accepted on our website, in which, by the way, anyone can submit to. It's just a study on how massing affects energy performance, and is simple, is understandable, is well laid out, and conveys a lot of information with very few words. Next slide. There's another one also that it studies the impact of HVAC, and which is HVAC on energy use intensity, which is essentially very it could be very complex. It could be a lot of data, but it could be also presented in a nice way. Next slide. So this is our mission. This is how we are. We're again part of ibpsa-usa, and our mission is to best communicate the results of building performance and essentially in any questions that our clients or architect friends could have. And you can, we have a website, of course. Their website is projectstasio.ibpsa.us, where you can see all the previous submissions, including the ones that are going to be presented today as part of our competition, and just independent submissions. So if you have something to show that is cool, that it communicates the idea, and that is visually appealing, please do submit it. Send us an email there on the website, on the link on the website, and then we will incorporate it. Without further ado, back to you, Guangzhou.
Yeah, thanks, Afonso. And this year we hosted our annual competition as usual. The call for submissions opened in April with a deadline in June. Later, the jury review took place over the summer, and now we are here today to announce the winners. This year's competition invited a jury team includes 4 experts from academia and the industry. So they are Junko Nakagawa, Alpha Yacob, Jesse Walton, and Kelly Hody. Thanks for all of the juries. And overall, we received over 10 valid submissions and selected 3 winning graphics. So first, the honorable mention in clarity. The winner is Lauren Gunther. Let's hear about her graphic story.
Thank you, Gonzalo. Next slide, please. So this presentation focuses on the main question, which is how does policy impact energy use? And this really relates to the Massachusetts energy codes. Next slide, please. In 2018, I became a certified Passive House consultant through Passive House Institute US, also known as PHIUS. And Passive House is a rigorous building certification standard focused on energy efficiency. So how it really started is I became interested at that point in understanding how many passive house projects there are in the world, and started collaborating with my husband, Moritz Gunther, to map the number of passive house projects there are in the world. And so here's a map from 2022 showing both the PHIUS and Passive House Institute, also known as PHI projects. And you can see in 2022 that there are 963 passive house projects in North America compared to over 4,000 projects in Central Europe. Within 3 short years, the number of passive house projects in North America have nearly doubled to more than 1,800 or close to 1,900 projects. So the question becomes, how does this increase in passive house projects occur? Next slide, please. In 2023, the Massachusetts energy codes had changed significantly based on Massachusetts' commitment to getting to net zero emissions by 2050. The energy codes established by the Department of Energy Resources are organized into 3 buckets, where each bucket is filled with more requirements. The base energy code is our minimum energy code in Massachusetts based on IECC 2021. And then the stretch energy code is stricter than minimum energy code and applies to new buildings and existing buildings. And it's available through municipal vote. And then finally, the strictest energy code in Massachusetts is our new specialized opt-in code, which is applies to new buildings only and also available through municipal votes. So understanding these energy codes is really essential, especially if you're a firm like ours, DeMello Schaefer, which works across multiple Massachusetts towns, and stricter codes are really optional. So you have to really stitch this patchwork together. So if we go to the next slide, please. In winter of 2023, we created this live map, which lives on our website, and you can click on any town or city in Massachusetts and see the effective energy code date. So the light green represents the base energy code, of which there are only 50 communities left in Massachusetts. The medium green represents 246 stretch code communities, and the dark green represents 55 specialized opt-in code communities. And of those 55 specialized opt-in code communities, there are 10 fossil fuel-free communities, which are indicated in purple. So these 10 communities are part of a pilot program in Massachusetts that eliminates fossil fuels for both new construction and major renovation projects. So we regularly update this map aligned with the Department of Energy Resources tracking. And then over the past 2.5 years, we've made 26 updates to this map, and it remains our second most popular blog post. So you go to the next slide, please. So Massachusetts is essentially where Passive House is code minimum. And what I mean by this is that our specialized opt-in code, which is that new energy code, is required for residential buildings greater than 12,000 square feet. So and in addition to that, Passive House is an optional pathway under our stretch code. Next slide, please. So getting to the graphic for the project Stazio's submission, this past year, when I learned about the competition, I thought about how could it be interesting to correlate the energy code adoption with the number of passive house projects in Massachusetts and to see if there was a shift before and after the new energy code adoption in 2023. So again, looking at how this all started, it started back in 2009 when the stretch code became available for town vote. And then what you see is the Massachusetts adopted the stretch code kind of at a slow rate. The first passive house project in Massachusetts was built in 2011, which is represented by a black dot. And then really just really want to acknowledge that these early projects are essential for energy code adoption because they prove that something is possible before there is a policy change. And what we see happening in 2023 is that towns rapidly adopt the more stringent specialized opt-in code and the fossil fuel free code. And there is an increase in both PHI and FIAS projects. Just and each one of these black dots represents 40 to 60% reduction in energy use, which is pretty significant. So this data only goes to the spring of 2025, so I expect there would be even more projects at this point. And it really demonstrates how key policy is to energy use reduction. And I hadn't really realized it being in kind of my bubble of architecture for so long. So really when the code requires it, there is definitely a momentum shift here. So the next steps would be for continuing to track the number of passive house projects in Massachusetts. And then finally on the last slide, so we continue to support just data and graphically showing data. So here we were asked by Zero Carbon Massachusetts, who has been very a leader in the fossil fuel demonstration program legislation, to continue to show how this shift in energy code adoption is happening in Massachusetts. So we're using data to really advocate for a growth in these policies. And here we're showing the fraction of the population which lives in communities with certain energy codes, and really how the base energy code went from being the dominant energy code 16 years ago to now only making up 10% of the population. So the question is, what will happen next with this policy? So thank you.
Thanks, Lauren. Next, the honorable mention in insightfulness. The winner is Kate Brand. Let's hear about her graphic story.
Hi, everyone. Guanzi, you can go ahead and go to the next slide. Thank you. My name is Kate Bomar. You might recognize me by my former last name, Kate Bren. I'm a professional architectural engineer, and I work as a building performance engineer with IES. Before I made the switch to IES, I worked as a consultant in energy modeling for 2 years on the commercial side at Cyclone Energy Group, and then also 2 years on the single-family residential side at Positive Energy. I recently relocated to Seattle, and I have bachelor's degrees in architecture and architectural engineering from the University of Texas at Austin. I'm a regular contributor to Project Stasio, and I'm on the ibpsa-usa board. So this graphic that I submitted to the Stasio competition comes from a presentation that I gave at Cyclone's annual Innovation Rodeo. I spoke for about 5 minutes on 10 slides, and my Cyclone colleague, Alan May, had encouraged me to think more critically about what sustainability means when we study building performance. So I took this presentation as an opportunity to do some research on the topic. In this presentation, I discussed how the answer of opting to use gas versus electricity changes depending on what building performance metric you're looking at. So if we're looking at a per unit of energy basis, gas is cheaper and less carbon intensive than electricity in most states. But because electric equipment can be 2 times or more much efficient than gas equipment, reduced energy usage offsets the difference in cost and carbon. But if we're looking at longevity, gas HVAC equipment is shown to have longer lifespans than electric equipment and water heaters, and it's also less expensive to maintain. We can also see that cleaner sources of energy lead to fewer deaths and GHG emissions globally. And the electric grid is also continuing to become less carbon intensive. So electricity will soon be less carbon intensive than gas on a per unit of energy basis in most e-grid regions and states. Next slide. So the key focus for this graphic that I submitted to Stasio this year is on the subject of gas versus electricity relative to carbon emissions. So this brings us back to the electric grid. If we're looking at 2022 EPA e-grid data, New York is the only state with an electricity grid that emits less carbon per unit of energy than gas, per unit of electricity than gas. So in New York, the annual electricity makeup emits 275 pounds of carbon per megawatt hour, whereas natural gas emits 399 pounds of CO2 per megawatt hour, equivalent because we don't typically measure gas in megawatt hours. So this map on the top right demonstrates emissions of energy of electricity divided by those of gas, which helps us understand how much dirtier that electricity is relative to gas in each e-grid region. Lastly, on the bottom right, what does the EPA predict? Based on 2023 data, about half of the e-grid regions are expected to emit as much carbon as gas per unit of energy by 2030, and most remaining regions will catch up by 2035. So as a part of the larger story of discussing electricity versus gas, and when we think about sustainability, this graphic tells the story that most states currently have electricity that is dirtier than gas, but predictions show that electricity will be as clean as gas, if not more so, in most electricity grid regions by 2035. So now to tell the story of how these graphics were created. The pie charts on the left were created using Google Sheets, and the two images on the right were generated with a combination of Google Sheets, ChatGPT, and Python. So I'll talk more about that next. Next slide. So the eGrid Power Profiler is a really great resource for understanding emissions relative to electricity grids across the United States. And I wanted to understand and translate that data to see how electricity emissions relate to gas emissions and how much that math changes as the electricity grid becomes more reliant on renewable sources of energy that are less carbon intensive. So I had the idea that I wanted to create these graphics to display, but not how to generate them. So I brought the idea to ChatGPT, and it suggested a 3-step workflow involving gathering emissions data, utilizing a mapping tool or Python library to generate the map design, and then customizing the output to incorporate company colors. I had never been a Python user, but I've always been interested in it. So I liked the idea of trying to accomplish this with Python. So then ChatGPT walked me through how to download a coding platform and library installation. I also asked it where to get the eGrid regions map so that I could overlay the data on top of it. And ChatGPT told me that the GeoPandas library doesn't come with an eGrid region, but I could download a shapefile from the EPA's website. The other supporting file I used for this code was an Excel file where I post-processed the eGrid region data in relation to carbon emissions per eGrid region. Next slide. After I got the first draft of this script, I asked ChatGPT to modify it to match my specifications. And this helped me learn a lot about the type of language that ChatGPT responds well to. And on the right, I'm showing an example of where I came up with multiple ways to describe what I wanted the script to do in order to come up with the intended outcome, which to me as a human seemed pretty simple. I just wanted to make the output image 5 times larger. I also finagled the script to add in debugging statements so I could figure out where specific issues were occurring and exclude unnecessary details like x-axes, y-axes, tick marks, and borders. I also opted to, instead of reformat the legend, I just created one in Google Slides for simplicity. And I printed the preview image, but it would also save a different image as an empty output image. So the issues that I encountered point to both my lack of skills as a programmer and ChatGPT's limitations. So ultimately, I was able to come up with a working solution that led to the results that we just saw. And after this project, I used a similar workflow to develop a live water quality test result dashboard for a well project. And I've since switched roles, so I'm not sure what's next for me in my coding future, but I'd love to keep playing around with Python, whether it be taking a class or doing some more ChatGPT workarounds. So time will tell.
Okay, thanks, Kate. Next, the overall winner of this year's competition is Jie-Wei Li. Let's take a look at his graphic.
Hey. Hi. I'm Jie-Wei Li from Good Clancy. Next slide. Okay, I'm going to talk about how I revisualize outdoor thermal comfort, and how we play around UTCI metric. So first, what is UTCI? So sometimes I just tell my colleagues that that feels like temperature. That's the actual temperature that you feel like when you're walking in the street. And technically, the number is close to air temperature, but also impacted by solar radiation, humidity, and the wind. For example, if the air temperature outside is 70 Fahrenheit today, and it's also windy and cloudy, which means no sunlight, you are likely to feel like colder, and the UTCI might be dropping to 60 Fahrenheit. And this result also fall into a 10 category feeling system, from extremely hot and to kind of hot to thermal okay and to cold to extreme cold, things like that. So next slide. How we usually visualize UTCI. What you are looking at is we called hourly heat map of UTCI, and it basically tells the UTCI result every hour in the year. I'm gonna further explain it for people who first see it. Next slide. So, on the horizontal axis, left to right, that's a timeline of the year. Vertically, from top to bottom, that's the 24 hours of the day. And in total, all little squares you see in the chart represent the UTCI result of the 87, 60 hours in a year. And also looking at the legend below, you can see the 10 feeling category color coded back into the chart. Then you can read something like, okay, in the winter it's mostly blue, means cold. In the summer at noon, that's kind of orange and red, that means hot. And the green color will tells you when you feel neutral, no thermal stress, or you can say that's comfortable. So just in case, if you enjoy reading numbers, check out the accumulated hour of each feeling category below, and that's the hour of each feeling. For example, you're gonna feel 1 hour in the year of strong heat, and you are not gonna feel extreme heat in this climate. But last but not least, the little joint on the left you are looking at, that's kind of to remind you that that's the natural outdoor condition. You are totally exposed to the sunlight and the natural wind. So that's a lot of information. Every time I would feel a little bit sweaty after I explain that to my colleague, but it's not finished yet. Next slide, please. Next slide. Yes. So because we can actually overlay the passive strategy like shading from sun or getting protected from wind or having both of them, it would actually come down to 4 sets of UTCI data. Imagine that you can compare how different strategy impact your thermal comfort, and maybe also understand when's the good time to use some passive strategy, and how to maximize the time you can stay outdoor comfortably. All the answers are hidden in this graphic in one image. That's very powerful. I kind of like that. But it's also overwhelming and complex. It could bring frustration to people who look at it for the first time. Next slide. We get a lot of feedback from our designer, from our teams, and sometimes also from the client, telling us, okay, we loved it. It's really helpful, especially once you understand what is UTCI, what is outdoor thermal comfort. But it takes time to understand it. And also, when you look at it, you just feel overwhelmed with all the information. And most importantly, for our designer, this feedback is that it's so complex and nobody really want to talk about it. This image or some analysis based on this will not even go to client. That's the problem. So there's something we have to do. First, simplify the language and clear clarity the visual, and also you need to laser focus on the content you really want to convey. Something we did, and I want to highlight there is we try to hide some too technical terms from the audience and then simplify the 10 feeling category into just 3. Think about it. You just need cold, comfort, and hot. Maybe that's good enough. And also, instead of looking at the whole year, we look at a more meaningful time scale like season, month, or just some hours that you actually use the outdoor space. And then tailor the visual, try to not to answer all questions in one single graphic. Next slide, please. We did many graphic iterations during the project work and synthesize the number, split the time frame into seasons, and highlight some meaningful numbers for decision making. And also that's the work draft that we did just for visualization. And all these efforts and the study comes into a research work and put up to a conference that showcase different visualization with UTCI metric. And one of the most successful graphic is the UTCI calendar or the thermal comfort calendar. Next slide, please. So the reason that is very successful is kind of intuitive. We call it a calendar because it really looks like a calendar. So we split the time into different months from January, February to December, and we split the day into morning, afternoon, and evening. We cut off the nighttime because that's the time you maybe not worry. Maybe people don't spend time outdoor. And also we only use 3 different color to color code our feeling. That's cold, comfortable, that's cold, comfortable, and hot. If you look at the upper graphic, you can kind of get the idea on in which month, during what time in the day, you're gonna feeling cold or comfortable or hot. That's the idea. And imagine that you can check your passive strategy like shading and windbreak. And you really want to understand, okay, for this time frame, what's the best strategy and how this strategy can actually bring up my comfortable time. Then that's the optimized strategy calendar below. So you can find out that some previous red and blue time block actually turned into lime green in the bottom graphic with the comfortable time increase. And there are many ways to use this graphic, but I want to highlight, I want to make some examples like you can identify the potential time of using the outdoor space in a year. Imagine that you have a client and this client want to understand, okay, I have some outdoor, I have an outdoor space that I want to use, and what's the potential that I can extend the time to use this space? And boom, use this graphic. And also you can try to understand, okay, what's the best passive strategy for some specific time frame? And then you can just search the circle, search the squares and search the time. and understand what's the best strategy. I think that's pretty much of the idea of it. And thank you for listening.
Yeah, thanks, Yewei. Now I'm sure we all have some questions about the stories behind those graphics. I'd like to have Sarah Makadasi, who will moderate the Q&A session for us.
Yes. Hello, everyone. Thank you for joining us today. Please feel free to drop your questions in QA box, and we'll make sure to get to as many as we can. Have a question for Lauren. So as you know, Project Stasia emphasizes on clarity on communicating technical results. Who was your target audience, and how did that influence your visualization and storytelling choices?
Thank you. Yes, so my target audience is really the AEC community, really the architectural engineering and construction community. We started that map in winter of 2023, and it really was to internally and externally communicate to other designers in the field of kind of help them understand where the adoption of the different energy codes was occurring. So it was really to first start with them, to kind of create an easy to use tool that's updated and live. And then eventually the idea of correlating it to the passive house projects has been used to really communicate to the greater industry of how much policy is impacting energy use reduction in Massachusetts. So it's kind of going to a greater audience, like owners and policymakers, and Passive House Massachusetts is one, but just communicating to the greater industry of how much policy can impact what we do, how we design our buildings.
Yes, thank you. And I have a question for Jerry. So what was your biggest challenge that you faced, either technically or in analysis part or the creativity part of showing your visualization, and how did you overcome that?
Okay, I think the biggest challenge for this project was to really create a digestible visualization, as I've been using this metric for years, and for many cases, I was really struggling explaining what is this, what is that to my audience, and even I get 5 minutes or 10 minutes explaining everything. I try to be as detailed as I can, but turns out it doesn't work. Then I realized, okay, I have to really be targeted on my presentation strategy, or more importantly, on the visualization. Because my audience are mostly architects, and sometimes they expect to bring your slide to the client and explain this idea to the client. You have to make sure your information is keep enough technical information so you can explain to the intelligent mind, oh, what's happening and why is that. But also you have to give them information that can kind of lead to their design decision in that way. So the best my solution to overcome it is just try test your visualization and keep iterating and keep communicating with your team.
So thank you. And I'm gonna ask a question from Kate. Kate, how did you decide what analysis to focus on and how to visualize it in a way that will communicate that best to your intended audience?
Sure. So I wanted to understand what the electricity grid was doing emissions-wise relative to gas emissions. And it seemed like when I was having conversations with clients, it wasn't obvious. And even when I was doing energy analysis myself, it wasn't obvious why, a building would be emitting more carbon or less carbon when you were looking at gas versus electricity. So I wanted to look at that data that the EPA has already and better understand and be able to demonstrate to clients like why it is that we're seeing the results that we are and why heat pumps are so important, because the efficiencies of them are so much higher than gas equipment. And but also, even if you do use a heat pump, it still would be it could be still more expensive than gas because electricity is so much more expensive than gas in most states. So all of those kind of questions were things that I wanted to answer throughout the presentation, and some of them I touched on in that graphic. We did use it to speak to clients, and from the get-go, it was intended for a client base of Cyclone, so a lot of native Chicago AEC building owners and other consultants. And that was interesting because local Chicagoans know their grid well, and the Chicago grid is actually distinct from the rest of the E-grid region of Illinois. And so I, got a specific question from the audience, did you use the Chicago grid region or did you use Illinois? And, so I had to make sure that I had data that reflected that specific client base, the knowledge base of those clients, even though I'm not native to the area. I had to make sure that it made sense to them.
Thank you, Kate. Now that I have you here, so if you could give one piece of advice for someone entering the next SASIO competition, what would that be?
Sure. I mean, I think that everybody, listening to this webinar is already doing the right thing. I think that there's a lot of great open source information that Project SASIO has available. I think there's, great webinars that SASIO has done as well. Jesse, one of the reviewers for this year, had a webinar this last year as well. So there's a lot of great resources online. And then you can also take a look at Project SASIO's database as well for graphics, kind of when you're wanting to understand what it is that you want to produce and how you might get there.
Thank you. And I have one more question for Lauren. So looking back, what key lesson did you learn from this project that you would say you would carry forward in your future work or in your collaboration with your teams?
Yeah, I think is really just one key lessons I've been learning with like just any of these graphics is like how clarity is so important for the communication to anyone. Because if you're dealing with this on a day-to-day basis, a very complex like topics or aspects of architecture, not everyone is familiar with it. So making graphics that people can understand pretty easily and see the impact has been a big lesson that I continue to take to any sort of presentation or analysis that I'm working on. And that just I'm trying to also think in terms of another aspect, but that's probably the biggest lesson is just how to keep editing and creating clear graphics so others can really understand it.
Thank you. Kate, I have a question for you. Did you use the subscribed version of ChatGPT? And the audience is wondering if the free version will offer robust feedback on Python scripts.
I used the free version and I still have I guess I'm out of memory now with the free version, so that would prevent me from using it next time. I couldn't, refer to it years later. But you can definitely do what I did with the free version.
Yeah. And we had a question from audience about if they are getting the presentation, access to presentation slides that I let Alfonso respond to that, if we can share that.
I believe we need the permission from the presenters and also from ibpsa-usa. But the graphics will be on the website. That's for sure. The winning graphics will be on the website.
Thank you.
Yep.
And that was the questions that we had. So thank you so much for everyone and for participating.
All right, we are almost at the end of today's session, and we will continue to host the competition and webinars for the next year. So please stay tuned for future events. Thanks all.
Thank you.
Thank you.